Hey, what's going on everybody? And welcome to this video. I want to run through a vector problem, and I think it's very representative of what you'll see when dealing with vectors in a physics context. However, for this example, there will be no application. It's just really working through practice with vectors, which can be challenging, especially if you're not well practiced with them. And so what we aim to do for this problem is find the unit vector for each of these vectors, vector A and vector B. And sometimes the biggest challenge with vectors is setting up the problem. And fortunately for us in this scenario, we're given the magnitude of the vector and the angle. But sometimes we have to calculate those and it can be challenging. But in our case, we are given those. So in order to find the unit vector for each of these, we'll start with A. We have the angle and we have the magnitude of this vector. So we can think of this vector as a line with a length of 3.6 meters. And so this would be represented as a hypotenuse if you imagine the unit circle approach. And so we want to find the amount of the x direction and then the y direction to find its coordinates. So we want to find the coordinates of this. And we can use our trig ratios. And so we know the angle 70 degrees and we want to know the x component first. And so we use cosine. Cosine represents this horizontal axis. You can think of it that way. And so cosine of 70 degrees equals the x over our hypotenuse 3.6. And we learned this in trigonometry. So we then use some algebra, and we multiply both sides by 3.6, and we get 3.6 cosine of 70 equals our x component. And so if we run this through a calculator, we get 1.23. So x equals 1.23. So we would move 1.23 paces in the right direction, in this case meters, and that is our x component. We also want to find the y component. So right here is the y component of this vector A. And so we have to use another trig ratio. In this case, we'll use the sine function because we're thinking in the vertical. We are thinking vertically. So we got sine of 70 degrees. Again, we're using the same angle. 70 degrees will equal y over 3.6. Again, do some basic algebra. Multiply both sides by 3.6. We get 3.6 sine 70 equals y. And if we plug this into our calculator, we get 3y equals 3.38. So you would move 3.38 meters in the y direction up. And so to write this as a unit vector, we just say that vector A is equal to our x dimension, which is 1.23. And we use this funny looking I hat to represent x. And then we add the y component, which is 3.38. And this is a j hat. And here we go. This is the vector, the coordinates. 1.23 in the x direction and 3.38 in the y direction. So if you're ever given the angle and the magnitude of a vector, you can calculate its coordinates using trig ratios. Okay? And we could do the same thing for B, but that'll just take time and be redundant. I will note that you might be tempted to use 30 degrees when using your ratios, using your trig functions. But the theta in this case is from our frame of reference is always this x direction on the horizontal axis. So write this part right here. So that's the beginning. And so our angle really is from here to there, so that's 180 degrees plus the 30. Really, we would use 210 degrees when using our trig functions. Okay, so that's the first thing I wanted to do. the next is, let's say we have to find a third vector, vector c. And so let's make some space. Let's use a different color as well. Use orange. So part B is, let's find a vector c, which is going to be equal to 3 times our vector a minus 4 times our vector b. And so we want to find a third vector, and we are subtracting these two vectors and after multiplying them by a scalar, in this case 3 for a and 4 for b. And so we would take this 1.23 and 3.38 and we would multiply it by 3. So we would just take 3 times 1.23 I hat plus 3.38 j hat. And then we would do 4 times the coordinates for the vector b, which I calculated earlier, are negative 0.8 minus 1.2. Oops, I forgot the unit vector. I hat minus 1.2 j hat. And so this is going to be equal to 3.69 I hat plus 10.14 j hat and then this is going to be equal to 8.32 I hat plus 4.8 j hat. And then we would add the x components together, so these guys. And the reason this is positive, even though these multiply to negative, is because we have to subtract them. So a negative minus a negative minus a negative is a positive, and so we would add these. You would add these. This would be pluses. And so we get our final components or coordinates for c, vector c, to be equal to 8.32 plus 3.69, so our x values, and that is 12.01 I hat plus our y's, which is 10.14 plus 4.8, which is 14.94 j hat. And so there we go. That would be our components. We would be 12 in the x direction and 14 in the y direction. But we don't know the angle yet. We could be over here. Well, we're going to be in the first quadrant, but we don't know what the angle is. So we would need to calculate first the magnitude as well. And so the magnitude will be, we would use the Pythagorean theorem. So we would go like this for c. Find the magnitude of this vector, which is going to be the square root of 12.01 squared plus 14.94 squared. And that is equal to 19.1 meters. So that's the magnitude of our new vector c, and that vector has coordinates 12.01 and 14.94. Now the angle of vector c is going to be, we're going to use the tangent function, and we want to know and the reason using the tangent function is because we want the y over the x, and so we can use the tangent function, and so we get arctangent, so inverse tangent, in order to find the angle. Because we know the ratio, we don't know the angle, so we have to use arctangent. If we knew the angle but we didn't know the ratio, we would just use tangent. Hopefully that makes sense. And so then we would do our y component, our sine 14.94 over our x 12.01. That's our ratio. and this is going to be equal to roughly 51 degrees. So we can imagine, we can imagine that looks something like, so we're going to go 51 degrees, so we're going to be slightly less than this, but the magnitude is 19, so much larger magnitude. Right here, this is vector C, and that's 19 meters, and then we can make this a solid line actually. So here's our new vector, 19 meters, and the angle is 51 degrees. This angle was 70 degrees. And so here we go, that's our new vector. And so this is a great primer on vectors and calculating them. And with that, we'll see you in the next video.